lecture 3 of this real analysis UPSC mathematics optional. Hope you all enjoying the lectures, in which way I am trying to convey the real analysis. So actually yesterday only I was talking with my student Dinesh, so he told me about that. He said pure maths के लिए there is not a one-stop solution for us. So please try to elaborate these concepts like you are doing already. So yes, I'm committed, I'm determined to do so. So let's start our lecture 3. And lecture 3 is completely dedicated towards a beautiful concept. Denumerable. Some people say countable and uncountable sets. One thing I want to clear, although this concept may seem very obvious to you guys, but you people may think that why sir is focusing on this concept, because UPSC is not much focused on that. PYQ says कि UPSC has not asked some like direct questions over this topic. So dear, you are a student and I was aspirant, now a teacher. So I understand. I tried to observe what is the pattern of UPSC. What happens is, if you talk to your seniors, they will tell you that pattern is being changed. And as a teacher, what I observed is, we have to stick on the syllabus but not sticking on the PYQs only. We have to think कि okay, if real analysis is mentioned in our syllabus, so yes, there is a possibility to have some question from this topic also. So always I suggest that don't leave any topic completely. Okay, if PYQs are being asked continuously, you can revise, you can practice that chapter, that particular point well, but that doesn't mean you will completely ignore some of the topics which are in the syllabus but not being asked frequently. So this is a beautiful concept. Again I will say, as the pattern of my teaching is, I try to open each aspect of a concept, because once you realize it, the life becomes easy. So for this topic, okay, in the starting only, today I am giving you a target, and the target is find a bisective. Bisective means 1 1 onto map. Map means function from open interval 0, 1 to closed interval 0, 1. So you have two possibilities, whether it is possible or not. Means you can find, and from here only I will start today's topic. How? If you are able to find a 1 1 onto map between this and this, I am saying if yes, then we may say that there is no difference between this and this. And difference doesn't mean element wise. Difference means these are some classes, you can say. Moreover, You will be surprised if I am giving you the next target as can we find a bisective map between this and this. So over the finite set, please focus on the word over the finite sets. We already studied 1 and 1 but now I am more interested in knowing about this. So let's start the chapter. This is target for you, okay? The next lecture, please let me know about this, whether this is possible or not. If possible, then come up with a formula like what is that f of x. And my chapter is being started from here only. So the thing I want to teach you today is, what do you mean by finite set, infinite sets? What is countability? Countability means, simple you can say, denumerable. What? Denumerable. If some people are from Hindi background, that is Gananiya, means you can count. If you can count, means you can tell what is the first element of that particular set, what is the nth element of that particular set, and so on. For example, if I say set of rational numbers, okay. For example, if I say set of integers, for example, if I say 2z, means set of even integers. So is this set countable? Means can you tell me what is the first element, what is the second element, and so on. Can I count elements in the set of rational numbers? You getting my point? One more question, please note it down. Does only finite sets are countable? Note it down. Are only finite sets countable? Question mark. Infinite sets are always, another question, always countable? Question mark. Infinite sets may give an example which is countable and which is not countable. You got my point? So that is the target 1 of the class, trying to know about countability. Okay bache, what we wish to have? Checking the countability of some given set. There are some beautiful concepts. Please don't afraid from the name. It is Cantor's. What Cantor's theorem says, if A is a set, then let's say PA is the power set of A. What is power set of A? Tell me. What is power set of A? Collection of all subsets of A is known as power sets of A. Okay. So what Cantor said, कि between A, please note it down roughly. Actually, this is the way of teaching. First we try to figure out what is the target of the lecture, then only we will be able to learn something. Otherwise we will be always in the panic situation कि पता नहीं what the next will be, what the next will be. So the thing is the consolidation. And believe me dear, from last 15 years I have been doing this maths, then only I am able to do such type of consolidation. And I want to deliver it for you all guys. So what Cantor said, कि between a set, suppose that you have a set A and power set of that set PA. So what Cantor said, कि between A and PA there cannot be defined a bisective map. याद रखना ऐसे स्टेटमेंट को. अभी इस पूरे चैप्टर में we will be using it. Remember it. So one is cantors. Have you ever listened about this aleph numbers? Huh? Hebrew words. Aleph. One word we will be using here, cardinality. Cardinal numbers. So what does that mean? Cardinality of set of natural numbers and cardinality of z or cardinality of q is same. That is our question of the lecture. Interesting ना कि how q का cardinality can be same as n का cardinality. And one more interesting question is कि cardinality of n or q, cardinality of q and cardinality of r can be the same or not. Ready? So as I told you Cantor's wala, from here I will come up with more beautiful examples, groups and subgroups here. Getting? So this is the beautiful concept for us. Now I will give you 4 to 5 points. The story is clear to you or not? Story mind में set हुआ कि why this chapter is very beautiful for us, because things we think that very obvious, but those are not so. Clear है अभी? Any issue? चल, let's move on. So, number first is, as I told you, real analysis, you may feel that everything is obvious, but everything is has a proof there. So please note down. Now start. Acha, notes you are preparing or not? If you are not preparing class notes, means you are not a disciplined student. Okay. See, I am coming from the lake ना, बारिश में भीगा हुआ है अभी. Still, I am determined कि I have to take the lecture. Means take the lecture. Okay. So you people please at least थोड़ा तो भाव देंगे करके. चल. So if I ask you what is finite set, and I will say don't laugh please. So as my dear students all knows कि I always focus on the definitions, because once we are clear about the definitions, everything is gonna be easy. So what is finite set? Don't think I am telling you only finite set. I will create a sequence. I will create a flow. So what is set? A set, capital A or you can say S, is said to be finite if there exists some finite n belongs to n such that f from S to n is a bisection, right, where n is just a subset of n containing n elements. So why I write such basic definitions? Because I have seen many people who are doing research, PhDs, they even don't focus on these things and they deliberately doing mistakes. So when I told you, when some given a statement or definition, when saying if there exists, means what is our target here? Please learn such techniques. You will feel very comfortable. What I say, if there exists such a finite n, such that this thing happens, means if there exists such n following these conditions, then we say A is finite. If there does not exist such n, we say A is not finite. Am I clear or not? Chal. For example, if let A is some A, B, C, D. So what I can say, A is a finite set. Why actually? Since there exists n equals to 4 such that f from A to N is a 1-1 onto map. 1-1 onto means bisection. Getting? Defined by, if I define f of A is equal to 1, f of B is equal to 2, f of C is equal to 3, f of D is equal to 4. And believe me dear, if you are in the habit of writing this, the things which seems very bigger becomes smaller. Because this habit needs to be developed in mathematics. Okay? Let's say if you want to say this is bisection. So people say showing 1-1 onto is a task. No. I told you in the group theory part. Showing this as 1-1 onto not a task. Finding such map is a task. Am I clear or not? So if not clear, then remind the video. So finite set ka definition is okay? Any doubt? Okay. Now I'm gonna start countable. What is countable set? Other is countability, or you can say countable sets. So what is the first task? Definition. A set S is said to be countable. A set S is said to be countable, or the other word we use, denumerable, if there exists a bisection, So what is the target when you want to check some given set is countable or not? Means finding such map, finding such bisection. Once you are able to find such bisection, then that is said to be countable if there exists a bisection between A and set of natural numbers. So please इसको box में बंद, do it and do remember this definition. Now I am taking some examples and beautiful examples. See, if you start the counting, whoever started the counting, so he or she must have some base, like some reference should be there. So for counting, our reference is set of natural number. What dear? Set of natural numbers. Means to check the countability, we need to have the base as natural numbers. Means with the help of natural numbers, we will check the countability. Is that clear to you? So if someone asks that Z is countable. Fine. Acha, one more task I am giving you. As I told you the definition of finite set, in the next lecture you need to tell me what is the definition of infinite set. Will you? चलो, पता नहीं, you will do that. Let of मनरेगा मजदूरी. I save your time. If there exists a bijection between a proper subset of that set and set itself, means suppose that 0,1 interval is the proper subset of R or not. So if you are able to find a bijection between 1 to map between this interval 0,1 to R, then R is said to be infinite. You getting my point? So not over R, you can talk about like n LO and 2n. 2n is 2, 4, 6 and so on. So you can find a bijection between 2n and n. So if this thing happens, then you say that set is an infinite set. So please note this definition also. What I can say is, in the interview, if some person is from the mathematics background and you have mathematics optional, then you may have such obvious definitions, and believe me, you will be judged over that. Because mathematicians, they cannot ask us to solve you questions. They'll ask some general terms. Even I am not from the mathematics background, still I am interested to know what is finite set, what is infinite set. Clear? चलो आपको बता ही दिया. Come on this picture. Z is countable or not? So what is the definition, बच्चे? A set S is said to be countable if there exists a 1,1,2 map between that set and set of natural numbers. So what I will do, पहले तो अपन we will do the मनरेगा मजदूरी method, okay? Then there may be n number of ways to get such bijection. For UPSC, that is more than enough. For persons who are preparing for others, क्योंकि कुछ TFR वाले बच्चे भी like design and all भी रहते हैं, so for them I will say, please take this as a basis question for you guys. They ask questions over this in the different kind of stuff, but base or theme remains same. Please mark star over here. Okay, so be it UPSC, be it TFR, be it IIT, be it any exam, I say any exam, interviews or written, you may face such basis. So to check Z is countable or not, what I do, अच्छा बच्चे बताओ, n is what? 0, sorry, I'm sorry, 1, 2, 3, 4 and so on. Z is what? Negative integers, 0, positive integers and so on. Now what I do is, let's say I map 0 to the element 1. Mark star over here. A very beautiful concept. What I do is, I just take a map F such that Z to F कहाँ से बच्चे? Z to N. So just to make you visualize, what I did is, I have written Z here. Suppose that I map 0 element of Z to 1 element of N. Suppose that this 1 I mapped to 2 of natural number. Suppose that this 2 I mapped to 4. Suppose that this 4 or 3 I mapped to 6 and so on. 1 1 जा रहा है कि नहीं? Is it 1 1 or not? Yes. Now what next I do is I map this -1 to 3. 3 of what? Set of natural numbers. Is that clear? Fine. -2 I mapped to 5. -3 I mapped to 7 and so on. So this is the set of natural number and very beautiful picture in front of us, mapping from Z to M. What I did, 0 is mapped to 1, positive integers mapped to even natural numbers, negative integers mapped to odd natural numbers starting from 3, because 1 I have already mapped here. Now check it out. This F is 1 1 and onto or not? 1 1, yes, because no two elements will have the same image. Clear? Onto, why I am saying onto? Because if you give any natural number, give me 10. So 10 will be mapped somewhere to some positive integer. If you give 2 lakh, some positive integer. If you give me some 2 lakh 1, will be mapped to some negative integer, means there will be no element in n which is not image of some element of Z. Clear or not? So बच्चे, what is the definition? To show कि Z is countable, what we done is we have shown कि yes, there exists such map F such that defined by this mapping, and F is bisection 1 1 on 2. So Z is countable. Any doubt? Any samasya? Okay. Clear है अभी? So please, I will suggest persons who are writing this UPSC optional, please be ready for the next, and persons who are writing like going for TIFR and all, they must focus on theme of this. Theme is what? Getting such bisection, and how we tried is negative integers to odd natural number, positive integers to even natural number, and 0 is mapped to 1. Am I clear or not? Chapko? So Z is countable. If Z is countable, then 2Z is मना कर देगा क्या? The same picture. So 2Z is countable. 3Z, 4Z, all are countable. 2Z is what? Set of even integers. Okay. Here I would like to tell you that if you can note it down somewhere, if A is countable, then any subset of A is also countable. Do remember this thing. So because just 1 minute before, people may think, sir, please show the bisection between 2Z and N. So don't try to show the bisection between 2Z and N. Just remember this bisection and show कि Z is countable. So any subset of countable set is again countable. So since Z is countable, so 2Z is countable, MZ is countable. Clear? Any doubt? Countability से? चल. So this is also called Z is denumerable, means you can tell what is the first element of Z, what is the fourth element of, what is the fourth element of Z? 2. What is the 10th element of Z? Some. What is the third element of Z? What is the seventh element of Z? This. So this is called denumerable. Okay. One more beautiful concept I would like to tell you here is diagonalization. Don't confuse with the matrix ka diagonalizability. Here diagonalization means something else. So with the help of that, we will move a set of rational numbers, that means Q, is countable or not. So let's say someone talks about Cartesian product n cross n, and he asks ki is n cross n is countable? Question mark. And this is not a simple question, this is a concept actually. Okay, so to prove these things, what we use is diagonalization. What is the diagonalization? Just I am giving you the brief. Suppose that I try to write the set n cross n. Okay, so how beautifully I will write that. Suppose that 1, 1 is the first element, 1, 2 is second element, 1, 3, 1, 4, and so on. Then write 2, 1, 2, 2, 2, 3, 2, 4, and so on. 3, 1, 3, 2, 3, 3, 3, 4, and so on. Similarly, I can write elements of n cross n or not. Any doubt किसी को भी? Now, what I do is I just give this as first element. Please notice here, first element of the set n cross n. This is the second and third element. This is first element, second element, third element. Now what I do is, this is the fourth element, fifth element, sixth element, and I move like this. Means if I continue this process, some people do like this, diagonalization. If I continue this process, means I am on the path of denumerability or not. I can tell you what is the 1000th element, what is the fifth element, what is the seventh element, and so on. So this is a very beautiful concept, that is diagonalization. With the help of this Cartesian product kind of stuff, you can show the denumerability. Getting? So let's check. Q is countable, set of rational numbers. That is our question. So this is a half target for you guys. Hint is diagonalization. Acha bache, how you write Q? Means elements of the form P by Q. So means any rational number R will be written as P by Q. There will be some, please focus here, there will be some P, there will be some Q. So what I did is, I will just represent this any rational number by P comma Q. And why I am doing so? Because if I am writing like this, I can frame the picture like this, like P1 comma Q1, P2 comma Q2, P3 comma Q3, and so on. And with the help of diagonalization, in the same procedure, it can be seen that Q is countable. Any doubt? Any issue? So those whatever we have learned from the minute 1 to the this time, our base is n means countability, we take base as n. So after n we have shown कि z is countable, then we have shown q is countable. So please do remember these things. These are your exam points. N, Q, Z all are countable sets. Is that clear or not? Any doubt? Should I move on? So A cross B kind of stuff. Acha, one more theorem for you guys. The statement is, acha, one thing I'd like to tell you, the beauty of, you are saying that I have no paper, I have no book. Still how much I am enjoying for this concept. Because not only this concept, the mathematics, because I have developed the flow. Actually I enjoy this. Okay, now the union will come, now this thing. And why I am not panic? Because I am very much consolidated. I know these are the 10 things, and with the help of these 10 things I have to do, I have to prove, I have to understand, I have to summarize. So that is the beauty of this learning all these comprehensively. So suppose that AIs are countable sets, then union of, like infinite collection of union of these countable sets is also countable. Okay, so you can say N union Z union Q. If someone asks in the interview ki N union Z union Q is countable or not, so you will reply ki yes, those are countable, because union of countable sets is again a countable set, and the base is simply finding the bijection or defining the denumeration through the diagonalization. Is that clear? So this is the part 1 of countability. Countability is clear or not for everyone? कोई doubt है तो please चिल्लाइए. चलो. So I want to move. Just give me 1 second quickly. Let's see. So yes. Should I remove this picture? बस थोड़ा सा hardly 10 minutes का concept is there, because investing 10 minutes will make your life easy for the whole examination process. Okay, now I am coming on uncountable sets. What dear? Uncountable sets. So what is the definition? A set which is not countable. Okay. So बोलेंगे सर इसमें नया क्या है? What's new in it? So a set which is not countable, mathematically you say कि there does not exist any bijection between, let's say S is the set, S and N. Okay? So in this words, like mathematically you can say. So other point is, please do remember this point, if a proper subset, if a proper subset of some set suppose that S of A is uncountable. Only 3 words I will give you here. Please listen with patience and note down also. A proper subset S of some set S is uncountable. Point देखिएगा. A proper subset. If a proper subset S of some set A is uncountable, then A is also uncountable. So this is the base for this uncountability part. Means, for example, if we wish to show that set of real numbers is uncountable, then we can show open interval is uncountable, so R is also uncountable. Means to show the uncountability of some bigger set, you just take a proper subset of that set and try to say that subset is uncountable, then its superset will also be uncountable. Fine. So this is the basis behind proving these uncountability part. Is that clear or not? Shabko? So how we prove that 0, 1 is uncountable? For this there are n number of ways in the real analysis. For example, if we see the Wordle and Sadword ka book, there is given that binary or decimal representation wala proof. Okay, so that is easy to understand. I have also written on your class notes. Other proofs are also there, but what I will suggest, go through this binary decimal representation wala point. The simple thing is, here you try to extract, please note it down, you try to extract at least core cheese, the core thing I am giving you, at least one element which is not the part of denumeration. Okay, so whenever we try to show some uncountability, we just try that this element, okay, first we start the countability. Let's say diagonalization आपने start किया, you just count, and at the end of the process you say कि this is some particular element which is not coming in this counting, so this set will be uncountable. So these are some basics behind that. Also, what the target I have given to finding the bisection between open interval 0, 1 and closed interval 0, 1. All those solved in your class notes also, which are uploaded in the Telegram group. So I am not bothering about कि sir answer क्या होगा. Answer is already given, but I will suggest you to think at least, because such beautiful concepts comes in years. Okay, so think. Then you will realize what the beauty in these concepts. Okay, so in this process we show that any open interval in R is uncountable, so R is uncountable. Fine. So what I need to remember is the first point, N, Z, Q are countable. Z ko how we show the countability, that mapping, please do remember. Third point, subset of countable sets is again countable, union of countable sets again countable. Okay, to show the uncountability we use either this diagonalization process में से extracting one element which is not coming in the denomination, or the decimal representation wala part. If you are interested, then you can go through the notes. Chal. Now I am coming on this second part का ही bit elaborated part है, but that is very beautiful. So please have patience. This last part of this topic. because cardinal numbers also I introduced. So I want to tell you something about cardinal numbers, how they came into the picture, and how the Cantor's theorem we use that. So one more proof for this uncountability here you will get. So write cardinal numbers or cardinality. See, cardinality means number of elements in that set. ये अपन बचपन से जान रहे हैं. We know this cardinality of a set is the number of elements in that set. So what happens? A set is finite, so means cardinality will be some finite number. If A is infinite, so finite set, तो उसका cardinality will be depending on number of elements, so some finite number. If A is infinite set, then how we represent the cardinality? So here we have two things. Number first is, see, finite sets always countable, so उससे तो अपने को कोई दिक्कत नहीं, no issues there. In case of infinite set, that may be countable and that may be uncountable. Fine. For countability, what is the base for us? N, Z, Q and all. Cardinality, in this case, cardinality is represented by a cardinal number L null, L not. Okay. अब here the Cantor Sahab comes into the picture. What Cantor says that there exists no surjection, you can say onto, or some people say bijection also, between the set and its power set. So for example, if A is 1, 2, 3, so what will be power set of A? 5, empty set, element 1, 2, 3, maybe element 1, 2, maybe element 1, 3, maybe element 2, 3, maybe elements 1, 2, 3, etc. So this is the collection of all subsets of A. What Cantor says कि between A and PA there cannot be a surjective map. अच्छा बच्चे, what is the number of elements in PA? Tell me. So if cardinality of A is n, then cardinality of PA is 2 raised to the power n. You can check it out. 1, 2, 3, 4, 5, 6, 7, 8. So if you can note it down, cardinality of A is n, then cardinality of power set of A is 2 raised to the power n. So those what it is representing as uncountability के केस में we have cardinal numbers as LF1, LF2, LF3 and so on. What is LF1 here? It is 2 raised to the power LF naught. This is nothing but 2 raised to the power LF naught and so on. Have patience. Because the thing may be I can skip these parts, but I don't think, because as the pattern is being changed, the topics which are not asked frequently, you must be aware at least about those. So if I want to say कि NZQ comes here and this comes the cardinality of R. So if someone asks what is the cardinality of R, that is 2 raised to the power L of null. Getting or represented by L of 1. Okay. So very beautiful actually. I am very happy for that because I enjoy it. See, I want to check whether R is uncountable or not. So what I try to do is एक map define करता हूँ N से R पर. Let's define some F from N to R, and if F comes to be surjective or be bijective, means on one and on two, then I will say R is countable, otherwise नहीं. Okay. So n का cardinality क्या है मेरे बच्चे? Alpha null means number of elements n is alpha null. इसका cardinality क्या है? 2 raised to the power alpha null. Come here. What it says? Cantor साहब कि between a set which has n element and a set which has 2 raised to the power n element cannot be a surjective map. So means not possible. So focus here. That is why I was giving that proof, because Cantor साहब did this very beautifully कि between a set जिसके पास n एलिमेंट है, a set जिसके पास 2 raised to the power n एलिमेंट है, इन दोनों के बीच में you cannot define a bisective map. So between n and r you cannot define any bisection. So R is not countable, and not countable means uncountable. Any doubt? Any issue? Should we move on? Beautiful. Very good. Okay. The last point, which may be target for you guys too. One second guys, please. So the last part what I wanted to tell you from the real analysis, now we try to move on for the group theory ka example. Let G be a group. And that is the beauty of doing these beautiful stuff. What I am saying is, let G be a group. So let G be a group. And order of G is, suppose that n. Let S be the collection of all subgroups of G. What I am saying is, let G be the group of order n and S be the collection of all subgroups of G. So what my question is for you guys, कि S is countable or not. So what we have proved here? Number of subgroups. So if n is the cardinality of G, then what is the cardinality of S? Means 2 raised to the power. So if this is countable, this is finite, then obviously this is going to be finite. Getting this Cantor's is of infinite, means finite sets के ऊपर तो you Cantor's is okay, subjection not possible. But this countability comes for if this turns out to be finite, then it is countable. If this turns out to be finite, then this is countable. So if G is a finite group of order n, so its all collection of subgroups will be finite also, and a finite set is always countable. A finite set is always countable. Any doubt? No. What happens if G turns out to be infinite group? Judge. So if G turns out to be infinite group, then there will be no bisection between Z and its collection of all subgroups. G and say sorry n और S के बीच में, so S will be uncountable. So this is one category. TFR also they have asked. These are some themes which can never be changed. So they frame questions based on themes actually. So that is one theme. One theme is also there, infinite sequences wala. Okay. So that is also I discussed in your assignment and class notes कि collection of all infinite sequences made up of, suppose that two elements 0 and 1. Like suppose that you can have the sequence like this, you can have the sequence like this, you can have the sequence like this. So what I say, suppose that this is the sequence S1, this is S2, this is S3 and so on. The question is, collection of all these S1, S2, Sn is countable or uncountable. So this comes under the same category. So please do remember these three subcategories. You will feel okay, I have done enough for this countability part. So yes, this was all thing. Even though I decided that I will finish this lecture within 30 minutes, but such beautiful concepts are there, because once these are clear, you will feel the real analysis. Okay, and if not clear, you will just mugging up that you are doing from you have been doing from this childhood only. Okay, so this is the part. The next lecture is going to be for real sequences, and from these 1 to 3 lectures, I hope you people are understanding what is the procedure of teaching and how we will finish the syllabus within 6 to 7 months. But stay tuned, keep practicing, keep revising the class notes which I am giving to you, keep solving assignments which I am giving to you. Stick to disciplined learning. Don't forget that disciplined learning. Telegram group is there, like there we can share everything. Any doubt you people can share there. I will definitely reply. Any question, anything, I'm always open. Okay, so stay tuned. We will meet in the next lecture. Till then, bye bye.